So Civil 3D Lab 2, for this class, we're going to be using the Civil 3D metric version because of the point data that we're going to be using for the lab is in meters, not in feet. So we want to make sure we start with the metric version. So instead of, your desktop will look a little bit differently than mine does, but instead of being able to just click the Civil 3D Imperial icon, you have to kind of dig into the program list a little bit and find where you see both the Imperial and metric. And you go ahead and select that, and it'll bring up the Civil 3D metric version, which will look exactly like the Civil 3D Imperial version. It just has all the configurations set for metric versions. So for this lab, we're going to be starting with a blank drawing. So you just want to make sure it's in metric and blank, and then we'll be adding point data to create the surface. So for Lab 2, we're going to be using some point data, and this is just showing the point data in Notepad. It's saved as a NEZ text file. So this is for the Provo River in Utah, and NEZ just stands for northing, easting, and Z, or elevation. So when we open up the data in Notepad, we see a single identifier number at the beginning, and then we see three pieces of data. So this would be the northing, the easting, and the elevation. Okay, so starting with our blank drawing, the first thing that we're going to do is create a surface. Last class I kind of explained all the various menus, but if we go over to this prospector menu and look at surface, you'll actually see that there's no plus sign, which is indicating at this point there's no surfaces defined with this drawing, which makes sense given that it's a blank drawing. So the first thing that we want to do is define a surface. So up here on the Home tab, we can see over on the second panel under Create Ground Data, we see this icon for surfaces. If I click it, you can see there's a lot of ways that I can bring in surface data, including I can bring in surface or create a surface from GIS data. But for this one, we're just going to start with a generic surface. So we say Create Surface, and it brings up the dialog box. I want to point out under name, a lot of these Civil 3D objects use a sort of convention where the first word is what kind of object it is, whether it's a surface or an alignment, and then it uses this counter notation, which essentially would start with 1, and every time we created a surface, it would increase this counter. So the first one would be surface 1, the second one would be surface 2. For this purpose, we're only going to create one, or for this tutorial, we're only doing one surface, so it's okay to leave it at that. I think it's good, to sometimes be more descriptive and actually say something like it's existing ground or whatnot. But we do want to put in here under the description that we are creating a surface for the Provo River. So under the styles, we could change how this surface is going to be displayed. So similar to the last lab where I showed you how a surface, I could change the different contour settings. I could show it as a TIN file. For this case, we'll just go ahead and leave it blank and hit OK. So all that creating a surface does is actually essentially just create a database, a place where we're going to store information about the surface. So if I look over here in my prospector menu, I now see that I have a plus sign and that I have surface 1. And so if I were to keep creating surfaces, I would have I would see more information about those. Okay, so now that we have the surface database sort of defined, we want to actually add data to it. So we're going to go up to the top under the Modify tab, and we're going to modify surface. And what this does is it brings up a surface ribbon. And then from that we can do add data. We want to add point files. That's the type of data we have. And then it brings up the add point file. So the first thing is just it's asking for the file name. So we want to go find it. It's under the lab 2 data, and we want the topo NEZ. So it brings it up. We can see a preview of it. It defaults. You can see that it's defaulting to this NEZ. It looks at the data and tries to guess what type it is. So we see that. We just want to confirm that it is NEZ, and then we can preview the data if we want it, and we can see how it is. Go ahead and hit OK. Now we are going to get a warning, and this is sort of intentional. Remember when we looked at the data, the very first line of it had the, I think it was 5182. So that was just a descriptor of the sort of sub-data set or the identifier with it, but that data didn't conform, right? It didn't have a northing, easting, and a Z elevation, so this warning is just telling you one point was ignored, the elevation was below a given limit, is what it says, but really it was just that it was non-conforming and it didn't have information. So we'll go ahead and close that. Okay, so now we have a surface defined, but we won't actually see it. One of the things I showed you last week is down here where I could turn on the coordinates. So when I started with a blank drawing, I'm out here just sort of in kind of a random coordinate space, but if I type in zoom extents, ZE, it'll bring me to where my data actually is. And so if I look down at the bottom, I can see coordinates that correspond to the data that we saw in the text file. So this is a surface. It's showing contour lines according to how I define them in my surface definition. And this green boundary is the outer limits of the surface. So anything within this green area I would have elevation information from. So similar to what we did last week, if I go over to Prospector and under surface properties, I could change my contours. So instead of just showing 2 meters and 10 meters, I'll show 1 meter and 5 meters. So I get more contours, right? So I can see where a little bit more detail about this river, right? So one of the things is thinking, well, how is, what direction is the river flowing? So now that we have a surface defined, anytime we sort of pause the cursor within the surface, it's going to give us information about what surface it is and also the Z elevation. So I can see up here on the right hand side, it's about 1,664 meters above sea level. And if I look down here at the left, the lower left, I see it's 1,660. So that tells me that the river is flowing in this direction. But while this is helpful when I'm within the drawing and I can pause my cursor, I might want to add some contour labels so that the drawing itself helps with the directions and information about that. So back up here under Modify Surface, this just brings up the surface ribbon. So I might want to add labels. This will do this. And there's different ways about, I can add spot elevations. I could do it on a grid, meaning like every 50 feet it would do a spot elevation like this. But what I want to do is add contour labels. And I can either do a single one where I just do a specified point and it's going to tell me label those contours, or I can do it what's called multiple times. So if I specify under this, if I specify the first point, you'll see I get this yellow line. And what this is going to do is it's going to label every contour that this yellow line crosses. So if I do that there, it's going to keep following me. I might want to put some there and maybe one more up here so I get contour information, and then I'll just escape out of that. So the good thing about Civil 3D is how sort of quick and automated pretty complicated steps are. But one of the bad things is sometimes it hides the data, right? So we were looking at the point data in Notepad prior to starting this. But once looking at the surface, we actually don't really have a sense of where those ground points were. We just know that it was able to create a surface. So one of the things we can do is kind of dig into the surface a little bit. So if I bring back up that surface properties, and instead of showing contours, I just want to show border only. So this will hide the contours, but we'll leave that green line. And then if I go over to the settings, so most of the time we're going to be in the prospector menu, but occasionally we want to get into the settings, which is just all the things that control how the Civil 3D objects are going to look. So if we go under surface, and then surface styles, and border only. So you'll see that this list corresponds to all the available styles we had in the drop-down list, right? So if I want to go into border only, I bring this up. So this is going to control what I see when I set my surface to a display type of border only. So over here under display, so this is it's showing all the pieces of information that make up a surface, and for border only I just have one layer visible. So this light bulb is turned on, so it's only the border. I want to go ahead and just turn the points on. So now we can get a sense of just how much survey data this surface was built from. So it gives us a certain level of confidence, right? That each one of these sort of crosshairs represents a point where a survey data point was taken. So typically streams are done in these sort of cross sections like this, and so they'll go out there, you know, with usually survey grade GPS now, and just take lots and lots of ground shots. So anyway, we can go back and change the surface style back to prospector and change our surface display back to contours. We don't actually want to see all the points now that we feel pretty comfortable that it was a pretty high quality survey that led to this surface. Okay, so before we move on to the creating the profile and the alignment, just a couple things back in that surface properties I wanted to point out. I did this pretty quick in the first lab, but if we change the surface style to contours and triangles, we'll see that TIN file, right? So this is that triangular irregular network, and so this is the way that we store elevation data within Civil 3D. So as I mentioned, that the vertex of every triangle was a survey point, and so now since you've seen the survey points, hopefully now the TIN configuration makes a little bit more sense. So it just uses straight line interpolation between any of these known points, and so the shorter the sides to any of these triangles are, usually sort of the better information or the more dense the survey points. But then you get locations like this where you have long straight lines between different survey points, and it's just using interpolation. So you could actually have, you know, a large sort of outcropping along your river, but this is going to portray it as a relatively flat, or at least a constant slope. So it's also good to look at the TIN because it tells you where you should have some doubts if you're trying to do design in here or estimate earthwork or try to, you know, build a structure along the river. You actually don't have much survey data in there, and so any of these points along the TIN should be considered really only rough estimates. So one other thing we can look at, instead of contours and triangles, we could look at elevation banding. So this is another way. It'll kind of tell us, it kind of looks a lot like some of the GIS maps that we would create, but it tells you, you know, for each sort of elevation, you know, so from high to low relative to what we have. One other final one is, instead of elevation banding, we could look at slope banding. So that's a way of graphically seeing where you have your steeper slopes and your flatter slopes. So there's lots of ways of visualizing your surface data. So we'll just go back. We're going to just leave it at 1 meter and 2 meters, and then there. So I wanted to point out one thing that's going to become useful when you go to do your project or you create your surface for the file, the roadway file that you're going to be using for your Civil 3D project for the rest of the semester. And over here in your prospector window, under the surface, there it's probably compressed, but your definitions. And these are all the things that you can use to create your surface definition. So it's all the different information that can be used by Civil 3D to define what the elevation of your surface looks like. And so for ours, because we went through the process where we used the menus up above and added the point files, you'll see that you have an indication here that point files are there. You could, if more additional survey data, you went out and maybe we were showing how it didn't have good surface information in this area. Maybe you sent your survey crew out, they got some additional points. You could go through and add those points in here, and it would take all the existing information and then also add that additional information. I wanted to point this out because for your project you're going to be using this contour feature and adding contours. So in that case for your project you're going to have contour lines that were drawn in or maybe digitized from a paper map, and you're going to be converting those into a surface. So in Civil 3D, there's often multiple ways to sort of do the same command, you know, by accessing through the prospector menu or accessing up here through the different pull-down menus. So it can get a little confusing sometimes. So the next major step we're going to do is to define an alignment. So we want to create a center line alignment that follows roughly the center line of our river. So by defining alignments, there are lots of different ways that we can do that. Maybe we had an existing alignment that came from a different map or was generated by the property lines or something. In this case, we want to draw a polyline, which is just a line, a series of lines and arcs that are combined into one unit. And we're going to use that to approximate where we think the center line of the river is just by looking at the contours, and then take that polyline and generate an alignment from it. So to draw a polyline, we can go up to the Hone menu, kind of look over in this Draw panel, and we'll see as we hover over that we have this icon for polyline. I tend to use the command line, and so I know that if I type in PL, it does the same thing as P-line or polyline. So I'm going to be just sort of approximating where it is. In this case, I don't want my O-snaps to be on, because otherwise it'll want to snap to these various contours, and I just want to use the contours as guidance, but I don't want to snap to them. So make sure that down here that you have your O-snaps off. So remember, if it's highlighted blue, they're on, and if it's highlighted white, they're turned off. So I just want to go through and draw. So polyline is just going to ask for a series of points. It's going to be just a line, various line segments. If you look down at the bottom down here, you'll see that a polyline has some commands within it. So it will default to just wanting to do line segments. So if I wanted to approximate, so up here where I have a large arc, right, it'd be pretty choppy for me to go around around this bend. I can see down here if I type in the word A, it'll convert to an arc. So I can kind of approximate the river bend that way. We also are going to be smoothing out the alignment in a later step, so I don't want to put too much thought into that, but I just want to, in a couple of these bends, it'd be hard to straight line approximate it. So the same thing, and once I move into the arc command, it's going to generate out. Now these are just arcs, these are not forced to be tangent, and you'll see that this kind of comes up later, that it doesn't require there be a tangent section between them, so they're not good sort of roadway design arcs, but they work for this purpose. If I want to go back to the line, I type in L, and that moves me back to straight line segments. If I don't like one of the segments I've drawn, I can type in U, and that means undo, right? And I can go back and do that. I'm using my transparent pan command by pushing in the middle of my mouse wheel. So down in here, it looks like the river kind of goes over in this case. down here, and there's something kind of weird with the contour lines in here. But when I'm done, I can just hit enter or hit escape. And so if I go and click on this, you'll see it's a single entity. Okay, now that I have the polyline drawn, I can use it to create my alignment. So up on the Home tab under this Create Design, we see a bunch of different Civil 3D objects, right? And this little asterisk, or this kind of orange and yellow asterisk, just indicates that this is how we begin creating these things. So if I hit the down arrow next to that icon, I'll see that I have lots of different choices for it. For your project that you do later, you're actually going to be using this alignment creation tools. From this case, we want to, since we already have an object drawn, we're going to create the alignment from objects. If you ever want any more information about any of these, you can hover over it and it'll give you a brief description. If you stay there, it'll give you a longer description. And in some cases, it'll even show you like a video version of what's going on. So an alignment creation tool is a little bit more common for roadway design, where you insert like the PIs and the various horizontal curves and whatnot. But for this case, we're just going to say click alignment from objects. It's going to ask what object, and we're going to select the polyline and hit enter. So the first thing it's asked is, it says, please enter to accept the alignment direction, and then there's a choice where it could reverse the direction. It's going to default to the direction that the object was actually originally created, and so we drew the polyline from this direction, from right to left, so it defaults to that, and I get this arrow. This arrow is indicating which way it's going to define the alignment. So we're going to define this river from sort of upstream to downstream. If I wanted to override this, and I could select this and it would go reverse and you'd see that arrow change. But I'm going to hit enter, and then it brings up the create alignment from options. And so a few things it's going to ask about. It's going to, we can put in the name. It's going to say it's the Provo River. There are various types of alignments. Most of them are roadway centric. Or rail-centric, I guess transportation-centric. So it could be a center line, it could be an offset. I could be creating maybe an alignment for the left bank or the right bank, or under miscellaneous. For this case, either center line or miscellaneous would be a good choice. Doesn't really matter too much. We have general. There's also this design criteria. This is really related to transportation and the speeds that we can select. I point this out because you're going to be using this for the project that you do at the end of this lab. So I can associate it with a site, similar to how we on the first lab we had different sort of subdivisions. We could say this road or this alignment is affiliated with maybe different phases of a subdivision. In terms of style, it could be, you know, a basic or proposed. What's this? It's also going to default to an alignment layer. It is very transportation centric, this program, so it wants to default to the road layer. So it's saying that if you kind of look, you might try to look for something that fit this. We could call it maybe a topo watershed. You know, find a layer. I don't believe it defaults or it has any standard sort of river layers, but when you go to do more complicated projects, and certainly when you go to work in the profession and work for companies, there's a lot of time and effort spent on using good layer conventions, so they would have their own default ones. But for this, we're just going to go ahead and accept it. We can just leave it on the road layer. Alignment style, or alignment label style, this sets how frequently and whether it shows the station labels and the tick points, like the half station tick points. It can also add like geometry points if you have points of curvature and whatnot. We just want to leave it as major and minor. And then here's the smoothing part. It's going to say, do you want to add curves between tangents? So when you have straight kind of breaks in there, do you want to smooth it out? And if so, what? How large of a curve do you want to put? We'll just go ahead and, I don't know, we can put whatever, maybe 75 to kind of smooth some of it out. And we'll hit OK. So if we look at it, remember we're using a metric convention, so our stations show up in metric. So we have our major station labels and our minor station ticks. and we can see that it's increasing. We also get this exclamation point, or this arrow. If I hover over it, it's saying that the tangency is violated, meaning that it's either unable to create a curve there, or it creates a curve such that one portion of it is not going to be tangent. This is the kind of thing that you get when you create alignments just using polylines, where the geometry of an alignment isn't strictly enforced. So kind of using route surveying principles. So for a river, that's fine. It's just giving you that warning. It doesn't mean that it won't execute any of the commands. It's just kind of telling you that this might not be considered good design, probably acceptable for a river, but not for a road. But anyway, we can see at the end that it goes to a little over a station. It ends at station 516 meters, right, from the beginning station. So now that we have the alignment created, I can zoom extents so we see the whole drawing. So now that we have the alignment created, if we go over here to the prospector menu, we'll see that we have our surface created, but now we also have an alignment. And depending on whether we had left it as a center line alignment or miscellaneous alignment, right, we now see that we have the Provo River down here. If we had, when we defined it, if we left it as a center line alignment, we'd see it show up in that place. But anyway, so we can right-click on the Provo River and bring up the Properties menu. So this is information about the alignment. This is where we define the style. We set it as type. We could change the type from here. It tells us about our station control. When we defined it, we left the station as the default, which is 0. But this is, we could go in and change it and say we want to use a convention of 10. Right? It tells us where we start, we end. We could apply that. Right? It's giving us a warning. Usually you don't want to make changes to the station except at the very beginning like this, because you may have drawn other objects based on these stationings and whatnot. So it gives you that warning. So it's something you usually want to do at the beginning of the alignment definition. So it has some other definitions about how it's showing its points of intersections or its PI points. But we can go ahead and hit OK with that. Occasionally you'll do something, you'll zoom and you'll see that these tooltips are kind of, these warnings can be annoying. In the most cases you would actually want to fix the problem as opposed to leaving it that way. You can see if I actually picked up this PI and moved it, I actually created a tangency problem with the previous one. So you want to be careful about using these grips. In this case, we're just using this as a demonstration, so it's okay that we have these errors, but when you go to do your project, these errors are something you'd want to fix, and you also want to be careful not to just pick up alignments and modify them in this way. There are other ways that we're going to be going through and showing how you modify them. Anyway, you can see some of these PI points. Because of the way it was drawn with a polyline, they're not very meaningful. They're certainly not correct simple curves. You can see all that. So the next thing that we want to do is create a surface profile. So we have this three-dimensional elevation surface and we have this alignment. And so the next piece is creating a profile where at every point along the center line alignment it pulls information from this surface about what the elevation would be. And it will give us some clues about whether or not we did a good job about defining where we thought the center of the river would be. So we want to make sure we have our alignment selected. So just to kind of point out, if I select the labels themselves, those are a different type of entity, and we'll see that up here it says gives me a ribbon dealing with the labels. So two separate entities, you want to make sure you select the alignment itself, and so up will come the alignment ribbon. So before I get into creating this surface profile up here, I just want to go back through a step that we had done in the previous lab, and this is using this geometry editor. So these are some things where we could create alignments or make modifications to alignments. by inserting additional PIs or curves. For now, we just want to bring up this grid view, which opens this panorama window. Remember, this thing can sort of live all over the place. And then we'll see the alignment view in a table format. So it'll give us information about the bearings of the different tangent lines, where they start and end, and any kind of curve information if it's a curve section as opposed to a line section. And we'll see these errors come up again. And once again, you can hover over them, and it'll give you information about those. So when you go to work on your project, this panorama window will come up and be much more important. For now, we'll just go ahead and get it out of it. We're going to live with our alignment however it is now. We're going to make sure our alignment is selected. So we bring up our alignment menu, and then we want to go over here and create a surface profile. So for this create surface profile menu, we will make sure that the Provo River, our alignment, is defined. You might have called it alignment 1, right? And then we want to select which surface. We could have multiple surfaces associated with a particular drawing. Probably the most common one is if you know you have different sort of rock layers, like maybe you have a hard bedrock surface and then you have your actual existing ground surface. You could have multiple ones, and through this you could want to sample from one versus the other, or maybe you want to have both. So in this case we only have one to select, so we only have one to add, but you need to make sure that there is a surface listed down here. Just seeing it up here doesn't tell the program that you actually want to create that surface profile. So we're going to go through and kind of go through all this draw and profile view. So most of these, it's going to go through each one of these as we hit next. If we wanted to skip and just go with all the defaults, we could create in profile view, which would skip to the very end and create the profile. In most cases, we're going to leave it as the default values, but I just want to spend a quick minute where you can see some of the things that you can change how it looks. So it's going to give every profile a name. It's using sort of hypertext, meaning that it's going to call it the Provo River, and then it's going to provide at the end this CP with for a counter for the profile. So it's going to create a profile window, and then it's just going to use this counter, so it'll just be called Provo River CP1. There's different styles, right, that you can create. Once again, we're just really going to go quickly through this and just let you know that you have some options. It's going to default under automatic to the very beginning and the end of the profile, but you could specify and create a profile for a sub area of that. So instead of the whole thing, you could just create a profile for a portion of your alignment. And it's going to look for the minimum and maximum elevations. So our profile range has a relatively small range in meters, but you could also force it to have specific min and max, similar to the type of way for setting up graphs in Excel. So specify which profile, meaning if I had sampled from multiple profiles, this would actually tell me which ones I wanted to show on my profile. I could have sampled from both the top or existing ground and the bedrock, but maybe I only want to show one versus the other. Okay. This is a lot of the styles, whether or not the stationing should be at the top or the bottom. Like I said, we're not going to spend too much time. You have hatch, so it clearly shows where you have cut and fill and different boundaries. But we're going to go ahead and create in profile view, and now it's going to ask for the sort of approximately the lower left part of our profile. And so you can see that it creates our station, and at each station it's showing elevation information. One of the defaults that we did was actually it's showing the elevation in 2 decimal places and 3 decimal places. But really, this is just at every point along the center line, it's telling us what our existing ground. So we can see that we didn't do a great job because the river should be running downhill, and we have a few places where it's picking up on some topography, whether it's boulders in the stream or things. But we have some areas where the topography is showing that we have uneven surface, and we probably weren't truly in the center line, and then we have some issues with some topography down at the end where it shows some sort of deep pools. But for what we're doing with this lab. That's acceptable because we're just showing how we would create a profile, and we just, understandably approximated. So here you can see, here's those issues that the center line was picking up where it dips down pretty substantially in those two pools. So it's a place where we could either go out and field verify that this really did happen, we could send the surveyors out to get better information, and we could work on our surface definition to try to get this fixed. But to start your Civil 3D project file, you want to make sure that you get out of the Civil 3D metric version that we're using for the tutorial part, and make sure you close that out and go ahead and bring up the Imperial version so that your units are correctly set. And then go ahead and open the project file. Be sure that when you take this Civil 3D project that you go ahead and rename it so that it has your name in the title as well, since we're going to be you're going to be emailing this to me at various times, and I want to make sure that you have your name as part of it. But when you get to this point and you have it named and saved back to your own file, take a look at what it has. It has 2 points, A and B. If I type in DIST, I can kind of measure the distance, and you'll see that it's a little under 10,000 feet between the two points. And I have this green alignment, which is the north alignment, and this yellow alignment, which is the south. And throughout the rest of the semester, the remaining labs, you're going to be developing roadway alignments and profiles and design for these two, and then using some cost calculations based on earthwork and some other major quantities of a roadway, and determine which one is sort of the preferred or better alignment. So I have, there's contours, there's 11 contours. If I were to kind of highlight and right click, I can bring up the properties, and you'll see that this contour has an elevation of 280, and if I were to do that to the next one, you'll see that it has an elevation of 320. So these are 40-foot contours, and they kind of rise up over this ridge. This will be the highest point. It has an elevation of 560, and then it goes back down to this contour at 280. So you're going to be developing multiple alignments, multiple profiles, and so you want to use a sort of strong naming convention. I would suggest using sort of north and south, not using sort of green and yellow, because as soon as you define the alignment, you actually won't see the colors, green and yellow. So the first thing that you're going to do, I'm not going to lead you through all the steps, is you're going to define an existing ground profile, or an existing ground surface, sorry. And so you're going to be kind of similarly following the steps where you create a surface and you name it, and then you're going to add surface data by kind of going over here to the prospector menu and under definition, finding that contour and adding all 11 contours. So there's a little bit I want to lead you through with the alignment steps, how you define an alignment. In this case, we're not going to define by objects. We're going to be defining an alignment kind of using a more sophisticated method, so I'll pick up on the video at that point. So for now, go ahead and define your surface, show them as contours to verify that it looks correct, and I'll pick back up when you're ready to define the alignment. So you should already have your surface defined and created by adding those contour information. Now that we sort of verified that the contours look correct, you can see that maybe this is an area where we don't have particularly good survey data, because it's going to just assume that all this is perfectly flat. But I'm going to go back over to the surface properties and change my surface to no display. So we're going to, so that way it gets us back to our original sort of drawing with just a few contours. Now remember, these are just sort of graphical contours, where the other contours actually have are based on the surface that's defined. So I want to lead you through defining this north alignment, just because it's using some slightly different tools than we did in the tutorial, and then kind of leave you on your own to finish up and do the south alignment. So how we're going to do this is we're going to go to Alignment under the Home menu and Alignment Creation Tools. And like I mentioned, as we work through these designs, your naming convention is going to be important. So I suggest using something like the north alignment. It's a center line, it's a proposed alignment, it's road. We want to maybe just change it to major and minor stations. If we leave it on, we can go ahead and leave it on all labels. You can always go back and change it and see what happens. So we're going to use some strong station conventions. We want to make sure that we don't have overlapping alignment numbers. So I'm going to go ahead and use a 10 plus 00 for the north, and I suggest using something 50 plus 00 or 60, something where you don't get overlapping stations. So if you're looking at a profile and you're in the tens, that it's clear that you're that you're in the north station versus the other. And so remembering that we had about 10,000 feet between the 2 points, you'd want to add at least sort of 10,000. So maybe you'd use 10 and 100 for the other one, but it makes it a lot easier to figure out what you're looking at when your drawing gets more and more complicated, that you have these different station conventions. So the other thing is now to go over to this design criteria. So design criteria, and by clicking on this, it says use criteria-based design. So this is where the program is going to link to design standards. It happens to be linking to this AASHTO 2011, what we call the Green Book. When you take transportation as a junior, we're going to spend a fair amount of time talking about what this design criteria is. For now, we're just going to say we're going to use it, and what it is it's going to size our curves, and it's going to check our design based on whether a vehicle could travel safely at 60 miles per hour. So we'll go ahead and leave that at 60 and hit OK. So all that does is create the database for where the alignment information is going to be stored, and then it brings up this alignment layout tool. So we've seen this before. We've been looking at this grid view a fair amount, but now we're going to start looking at some of the other things. So for the initial one, we want to go ahead and just draw in our alignment. So if I were to just default and leave it at this sort of A looking thing, it would I would be drawing in pure tangent alignments, no curves. So this would be good for like an early reconnaissance survey, but in this case we want to make sure that we're adding in with the curves. So we want to select this second one. So you'll see what that does. So make sure your O-snaps are on, right? So that we're going from endpoint to endpoint. So we're going to start at point A. We go to our first PI. And then as we start going to our second PI, you'll start to see that what it's doing is it's not just adding our straight line tangents, it's also adding in the curves, right? So it's pulled from that design criteria file. It says that this road should be traveled at 60 miles per hour, and it's put the appropriate curve size, minimum curve, in there. And so I want to go to the end and hit enter. So from that, if I go back and look, I'll see it starts at station 10, and because I selected all labels, not just major and minor, it put the station labels, the minor ticks, but it also added in where all of our PC and PT points, and then it puts a midpoint, for the point on the center line that's perpendicular or adjacent to that PI point. So we can see that. If I have that alignment selected and I hit grid view, I'll see this information in the panorama window. So you can see I have lines and curves. So it's pulled from the criteria file for 60 miles per hour, a design speed of 60 miles per hour. It says that the minimum radius is 1,500 feet. So in this panorama, I just want to show that this is where I could change. So if this is a minimum curve, I might be looking at my alignment and saying, I want to increase some of the curves. So maybe I want to go, maybe I'll increase this one because it's in the view. But if I increase it to 1,700, right, you could see that it dynamically adjusted that curve. It upgraded, recalculated where the PC, PTs, all the stationing along the entire alignment because I did that. I can also go lower. I could say 1,200 feet, right? the curve would get steeper, but then I would introduce these warnings, and if I hovered over them, it would say minimum radius. So for this part, you can change it. We're going to see who can develop the most efficient alignment with the least amount of earthwork. So you might want to, make some changes. But for now, just make sure that you at least have minimum curve length. I'm going to go ahead and change mine to this, and 2000. I'll change that one to 2000. And then if I zoom out, you'll see that it's increased this curve a little bit and increased that one. So I can see that. So through this process, you're going to go ahead and create an alignment for the south using this as a starting point. We'll go back and modify some of the alignments and at a later process, but we want to get preliminary alignments for both the north route and the south route, and you want to go ahead and create 2 surface profiles, a surface profile for each one of those. So at the end of this, you should have 2 alignments and 2 surface profiles. So just kind of going over to Prospector, you can see that I have this north alignment. I can go through and look at the properties of that alignment and see the various information that I defined from those. And then, so at the end of it, you should have a north alignment, a south alignment, and both ones should have a surface profile associated with it. So shouldn't take too long.